Okay students, let us see certain conversions of chapter number 6, haloalkanes and haloarenes. See, the first one is how you should convert propene to propanol. Fine, so let us start. You see that structure of protein is CH3 CH double bond CH2. Okay, now we first react it with HBr in the presence of peroxide. Now when we react it in the presence of peroxide, we say it should follow anti-Markovnikov's rule. Okay, anti-Markovnikov's rule. Now what that Markovnikov's rule says is the negative part of HBr, addendum is HBr, so negative part of the addendum is Br minus, has to be added to that carbon which has more number of hydrogens attached to it. Okay, just the opposite of Markovnikov's. Negative part of the addendum is to be attached to carbon having more number of hydrogens attached to it. So the product here which will be formed will be CH3 CH2 and CH2Br. Hydrogen will go to this carbon. So you get the product, and the name of the product is 1-bromopropane. Okay, now this 1-bromopropane has to be further treated with KOH because we need to prepare propanol. So now here when you add KOH, so you will see that Br is replaced with OH, CH3 CH2 CH2 OH, and KBr is removed. So this is how your propane 1-ol is formed. Propane 1-ol is formed. So that was all about your first conversion. Now let us take the second conversion, that is ethanol to but1-ine. Fine. Let us take ethanol. You are having ethanol as CH3 CH2 OH. This is your ethanol. When we react ethanol in the presence of red phosphorus with I2, okay, so you will see that your I will be replacing OH, so you will get CH3 CH2I, that is iodoethane. Iodoethane is your product. Now this iodoethane is treated with sodium acetylene. Okay, so that is sodium acetylene. This way we write minus, it is minus, this is Na plus. Okay, this is minus. Fine, what is the name of this? It is sodium acetylene. Now when made to react with this, you will see that this particular acetyl group will be added to your iodoethane, giving you the product CH3 CH2 C triple bond CH, and minus NaI will be there. So you get back your final product as but1-ine. This is your final product. Okay, now let us talk about the third one, how to prepare 1-bromopropane from 2-bromopropane. So now propane, so 3 carbons, so you are having CH3 CH2 CH2Br. This is your bromopropane. Now this bromopropane is to react with alcoholic KOH. Now we know that there is something called as beta elimination. So here in this case, this carbon is alpha and this is beta. Beta elimination we carry out, or it is otherwise referred to as dehydrohalogenation. Okay, it is otherwise referred to as dehydrohalogenation, where you will remove one hydrogen and one halogen. So when you are removing that in the presence of alcoholic KOH, you get back the product as propene. So CH3 CH double bond CH2. From adjacent alpha and beta carbon, you will remove HBr. From beta carbon you are removing hydrogen, and hence it is referred to as beta elimination also, or as I said, dehydrohalogenation. So this leads to formation of the product propene. Now this propene is further to be reacted with HBr. Now this is, Markovnikov's rule. What is it? It will follow Markovnikov's rule, where you will see that HBr will be added to the carbon having less number of hydrogens attached to it. So the product will be CH3, CH, Br and CH3. So this is your product 2-bromo-propane, utilizing your Markovnikov's rule. Okay. Now the fourth conversion is toluene to benzyl alcohol. Now toluene, you know that you have benzene and over that you have CH3. This is your toluene. Now this toluene is when made to react with, you do chlorination of this, but that chlorination we do it in the presence of sunlight. What will happen? The side chain of your toluene will be getting, one of the hydrogen of the side chain will be getting replaced by your Cl. Okay. Now this reaction takes place in the presence of sunlight. So when Cl is added, 1 mole of HCl is removed. Now this product which is formed is referred to as your benzyl chloride. We need to form benzyl alcohol. So further this we will be treating it with KOH. So you will see that you get back finally benzyl alcohol, CH2OH, and KCl is removed. This is your benzyl alcohol. Okay. Now next conversion is benzene to 4-bromo-nitrobenzene. Fine. So let us take benzene. You have this benzene. You are making its reaction in the first step with Br2 in the presence of FeBr3. Okay. So ultimately you are doing bromination of benzene. So you know when you are doing bromination, you will see that here on benzene you will get Br. This is bromination. You have done bromination. So you get back your bromobenzene. Now this bromobenzene is further treated with concentrated H2SO4 and concentrated HNO3. Now this reaction is referred to as nitration reaction. Here electrophilic substitution reaction will be taking place, where your electrophilic ion, that is NO2 plus, will be formed, which will attack your bromobenzene, and it will be taking its place at the para position. So you will get para-nitro bromobenzene, which is formed as the product required. Now here let me tell you one thing extra. Here when Br is made to react with FeBr3, actually it is Br plus which is formed here, right? Electrophilic ion, and then you are having along with it FeBr4 minus. So this attacks your benzene ring to give you your bromobenzene in bromination. This happens in bromination. Now what happens in nitration is your H2SO4 and HNO3, they produce your electrophilic ion, which is NO2 plus, and here you will have HSO4 minus along with water. So it is this NO2 plus which is attacking your bromobenzene. So the product you get is para-nitro-bromobenzene. Now let us see the sixth conversion, that is benzyl alcohol to 2-phenyl ethanoic acid. So we know the structure of benzyl alcohol. it is over benzene, you are having CH2OH. This is your benzyl alcohol. So let us see that you are treating it with thionyl chloride, SOCl2, and you will see that OH will be substituted here with Cl. So you and minus HCl and minus SO2 gas will be there. This is benzyl chloride. Now this benzyl chloride is further made to react with KCN, potassium cyanide, right, in the presence of ethanol. So what you will get back, that Cl will be replaced by your Cn. So here the product you will get will be CH2CN, that is 2-phenyl, this will be 2-phenyl ethane nitrile. The formula has CH2CN above benzene ring. The name is 2-phenyl ethane nitrile. Now this is further to be undergone hydrolysis. So you will see that you will get back over benzene CH2COOH. This is your 2-phenyl ethanoic acid, the product which we were in need of. Okay, this is actually here 1 and 2, so you say 2-phenyl ethanoic acid. Same way here it is 1, 2, so 2-phenyl ethane nitrile. So that was your 6th conversion. Let us see the 7th one, that is ethanol to propane nitrile. So here also we will see as above we have taken, right? Here we take your ethanol, that is your CH3CH2OH, which is ethanol. We make its reaction with thionyl chloride, SOCl2, and with release of HCl and SO2 gas, OH will be replaced with your halogen. So you form chloroethane as the product first. Now this chloroethane which is formed is to again make reaction with KCN as above we have done in the presence of ethanol. You will see that your product formed here will be CH3, CH2 and Cn. This is nothing but your propane nitrile. Propane nitrile. So these were the 7 conversions which you have seen just now of the textbook. All stepwise conversions are from 1 to 7 done here. I hope you have understood. See that you are making note of all these conversions. Thank you all.